All right, this is 4.4 factoring polynomials. So factoring means to kind of break apart. We've used the distributive property before, and that's kind of like the opposite of factoring. So distributing puts things together or multiplies things together. Factoring kind of divides things apart, or it breaks things apart. So let's read here. A polynomial is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. And that's a neat idea there with integer coefficients. We're not allowed to have a fraction, a decimal, or a root as a coefficient there. An expression of the form AU squared plus BU plus C, where U is an algebraic expression, is said to be in quadratic form. Now, we know a quadratic equation is ax squared plus bx plus c. But what here we have the u, meaning that maybe we can have something that looks really weird. Maybe it's like, I don't know, a times x minus 3 squared plus b times x minus 3 plus c. And that's going to be a quadratic expression that is in quadratic form, because we have a piece squared and then a piece with degree 1, and then we have just a coefficient on the end. So that's a little bit different. We'll use that later on, I believe. 21, we're supposed to factor completely. So this makes it a little bit easier. First off, we look for, is there a monomial that we can pull out? A monomial is something of degree 1. There's something that's I don't know, just plain old that we can pull out. You know, all three of these spots here, they have an x, so I'm going to pull an x out front. You know, and in some real sense, I'm dividing an x out, right? So I divide it out of the cubic term, and I get x squared, and then I have plus 8x, and then lastly, I have just a plain old 7. And then I want to look for how I could factor this. Oops. How I could factor this quadratic there. It's a quadratic trinomial, and we factored these before. If the quadratic piece has a 1 out front, and this one does, then we can really nicely just break apart the 7. So 7 is, 1 times 7 gives you 7, and 1 plus 7 gives you 8. So we can have the x hanging out front still. He just carries down. And then the quadratic piece in the parentheses can break apart to be x plus 1, x plus 7. And this is going to be the factored form. So we factored it completely. Let me rewrite it, just make it a little bit prettier. X times x plus 1, x plus 7. Makes it look just a little bit prettier. All right, that's number 21 there. 22, we're supposed to factor completely again. So I look for what could I bring out. We have numbers, the 2 and the 50. I could pull a 2 out. Then that would leave me with y to the 5th minus 25 y cubed. And then I want to look for, is there anything else I could pull out, right? So they both have y's. They both have 3 y's or more. So I could pull out 2y cubed and then have a y squared minus 25 left over. Now, the 3y cubed hanging out front, that is factored fully. But the y squared minus 25, that is a difference of 2 squares. And there's a formula that we might remember, might not. If we have a plus b times a minus b, and you multiply those, it'll be a squared minus b squared. And you might recognize that the a plus b, a minus b, those are conjugates, and conjugates cancel out the middle term. So right here what we have, we're going to have 2y cubed, and then because it's a difference of 2 squares, the y squared and the 5 squared, which is 25, we'll have y plus 5 and then y minus 5. And this here will be our factored form. The y squared minus 25, the difference of 2 squares there, that's something that people commonly miss. You know, on a test or a quiz, I can almost guarantee that there's going to be at least one problem that has a difference of 2 squares in it. And you're going to have to look at that, and you're going to have to recognize, oh, that's a difference of 2 squares, and then factor it apart like what we did here to break it apart that way. All right, that's 22. Let's look at 23. We look for, what do they all have in common? And I'm going to try to do this all together. You know how in this one we pulled out the 2, then we pulled out the y, so I'm going to do it all together. So they are all a multiple of 10, and they all also have at least one z. They all have at least 3 z's, actually. Whenever I pull that out, I'll have z squared plus 4z, and then plus 4. I try to factor this like I did the first one. I can get 2 and 2. 2 times 2 is 4, and 2 plus 2 is also 4. So this will be 10z cubed, and then z plus 2, and then another z plus 2. Now, when you have a repeated factor like this does, right, we have z plus 2 not just once but twice, we want to put that together. So we'd say 10z cubed, and then z plus 2 squared, right? To square means to have it twice, to multiply it by itself. And this is going to be our final answer. All right, let's look down at let's look at these definitions here. Special factoring patterns. Now, I'll be honest, these are not ones that I normally have in my head. I can normally recognize that we need to use them, but I normally have to look them up. So on a test, on a quiz, I'm going to give you these problems, or give you these formulas, or I just won't have it on a test or quiz. But we have a formula here. If you notice that you have the sum of 2 cubes, there's a formula that we can use. And if we have a difference of 2 cubes, there's a formula we can use. Okay? Let's look at 24. At 24, it looks like there's a difference of 2 cubes. So this would be x cubed minus 10 cubed. So my a is x and my b is 10. So I'm going to use this formula right here for a difference of 2 cubes. And this is going to be x minus 10 and then x squared plus 10x plus 10 squared, which is 100. And that's going to be our answer to this. Okay, these aren't difficult problems. The difficult part is just memorizing that formula, or not memorizing necessarily, but knowing to apply it. All right, let's look at 25 here. They both have a 2, they're both even, and they both have a y squared. So let's pull out a 2y squared, and we'll be left with y cubed plus 125. Now, this is a sum of 2 cubes. Let me rewrite it. 2y squared, and then y cubed plus 5 cubed. So we can apply one of these formulas, and it's going to be this top one here, because it has the a cubed plus b cubed. So our final answer, we still have the 2y squared hanging out front, and then we'll have y plus 5. Right, so I plugged it into this guy right here. Now for the trinomial, we'll have y squared minus 5y plus 25. And there we go. Let's scroll down. For some polynomials, we can factor by grouping. And factoring by grouping is a really neat idea where you take the first 2 and the second 2 and you look at them separate. So it has to have 4 terms to begin with. 4 terms means 4 different chunks. And the first 2, you pull something out of it. So in this one, we pulled out an R. The second 2, you pull out something. This time they pull out an S. And then you pull out the A plus B. And then left over is the R and the S. So that's what I'm going to do in problem number 26. We look at the first 2 and the last 2. Looking at the first 2, there's a z cubed plus 3z squared. I'm going to pull out a z squared, and I'm left with z plus 3. Then I want to pull something out of the second ones such that I have a z plus 3 at the end. So I'm going to need to pull out a negative 36. Now they both have the z plus 3, so that can come out front, z plus 3. And then left over is the z squared minus 36. And then we're still not done, because this is 6 squared, so this guy right here, this binomial, is a difference of 2 squares. So I can factor it to be z plus 3, and then z plus 6, z minus 6. And there we go. That difference of two squares, again, like I said earlier, it just kind of pops up in problems, and it's very common for people to miss it. So you always want to be on the lookout for any time you have a variable squared and then a number squared. So 36. So the numbers that you should be on the lookout would be 1, 4, 9, 25, 36, and so on. You can look at your other perfect squares. But if you see those numbers pop up in your problem, you just want to make sure that there's not, or you want to apply it if there is a difference of two squares. All right, that's 26, 27. We're supposed to factor completely. The first binomial, I could pull out a 2d squared, and I'd be left with d plus 5. The second one, I could pull out a 3, and I'd be left with d plus 5 again. They both have a d plus 5, so I pull that out front, and then left over is 2d squared plus 3. And that is going to be my answer. 28. We're supposed to factor completely. Now this one is in what's called quadratic form, because we could write this as n squared squared plus 11 n squared plus 28. So we factor it as if it said something like x squared plus 11x plus 28. But whenever we factor it, we can't just write x, we have to write n squared. So I look for numbers that multiply to be 28 and then add up to be 11. And I am thinking 7 times 4, 7 times 4. 7 times 4 is 28, 7 plus 4 gives me 11. So I'm going to have two sets of parentheses here, n squared plus 7, and then n squared plus 4. Now I see the 4 there, and that rings alarm bells for difference of two squares, but there's a plus there, so it's not a difference, it would be a sum. So that doesn't apply with that formula there. So this is going to be our final answer. All right, number 29, we're supposed to factor completely. W cubed minus 125. Well, that's w cubed minus 5 cubed. That's a difference of two cubes. So let's scroll back up and check on our formula. This is the one with the minus in it. So this is the bottom one. We're going to have a minus b, and then in the second one, everything's positive. So we're going to say w minus 5, and then we'll have w squared plus 5w plus 25. Okay, these formula, or the formula there always follows the same rule. We have an a and a b in the first one. Then you'll have a squared plus ab, or well, not necessarily plus, and then plus b squared on the end. I'm almost certain that it's always that way. Let's actually look. We have, yes, so I look at this plus, that minus, that minus, that plus. That's really the only difference in it. So let me scroll back down. This one had a minus up here, and then in the formula there, it had a minus there and a plus there. So that was that minus and that plus. The formula is very similar for both of them, though. So it might be a good idea to try to memorize them. But like I said earlier, I'm going to give you those on a quiz or a test. But for homework, it still might be useful to memorize them. All right, that is all. That was section 4.4.